Hi everyone. Um, Today we are going to start with integration by parts. It's a very simple concept. You can make a note of it. Okay. Now in derivatives, we had product rule and quotient rule. In integration, we don't have any product rule or quotient rule. Okay. So what we are going to do with certain problems that we are going to study over here right now. Okay. So the next part is the next topic is integration by parts, and the formula for this is integration of u into v dx is equal to u integration of v dx minus bigger integration dy dx of u integration of v dx bracket close dx. So this is the formula for integration by parts. Once again, it is integration of u into v dx, okay, is equal to u integration of v dx minus bigger integration dy dx of u smaller integration v dx bracket close dx. So this is the formula for integration by parts. Okay. Now terms u and v, these terms u and v can fall under any of the two categories out of these three. The terms u and v, the terms u and v will fall under any of the two categories out of these three. Okay, that is L, A, E, and don't change the uh, letters over here. It is in the same order. L, A, E. L is logarithmic. L is logarithmic. A is algebraic function, that is x raised to n, and E is exponential function, that is a raised to x or e raised to x. Are you understanding? So u and v, u and v can be anything out of anything two out of L, A, E. L is logarithmic function. A is algebraic function. Algebraic function is nothing but x raised to n. Then E is exponential function, a raised to x and e raised to x. Fine. Okay. So let's take up the first problem. Let's take up the first problem from your government textbook. Exercise 5.5, question number 1. Exercise 5.5, question number 1. Integration of x into log x dx. Integration of x into log x dx. Now log x is logarithmic term and x is algebraic term. Log x is logarithmic term and x is algebraic term. Okay. Now first and foremost, we need to rearrange this. We'll have to rearrange because the priority list is as per this L, A, E. This is the priority list. Okay, so logarithmic term will always be first and then the algebraic term and then the exponential term. Okay, but in here in our problem, they have not specified this in a correct order. So the logarithmic term will always appear first. So this can be written as log x into x dx. Okay, I'm interchanging the order. I've written log x first and then I'm writing x. So the logarithmic term goes first and then the algebraic term. Okay, now this can be taken as u and v, and this is not product rule. Okay, this is integration by parts. There is no product rule in integration. Fine. So what we are going to do is we are going to write a formula u integration v dx minus bigger integration dy dx of u smaller integration v dx bracket close dx. Okay, So this is the formula which I have written, integration by parts formula, the formula which I gave you, right? What I have done is I've taken log x as u, take log x as u, and take x as v. Okay. I will put the values in this formula. We will put the values in this formula. Okay. Fine. So this is equal to log x integration of x dx minus bigger integration dy dx of log x integration of x dx bracket close dx bracket close dx. So I'll take you to the previous slide. See, first step was interchange. First logarithmic term should appear. It's as per LAE. Okay, so logarithmic term should appear first. Then apply the formula. The formula I've written. After application of the formula, I'm going to put the values. So that's what I've done. I've put the values over here. So this is log x. Now integration of x is nothing but integration of x raised to 1. So integration of x raised to 1, this is right. So it is x raised to 2 upon 2 minus bigger integration d by dx of log x. This is the derivative part. D by dx of log x is 1 upon x, and integration of x raised to 1 is x square by 2, x square by 2 dx, x square by 2 dx. Okay. Derivative of log x is 1 upon x, integration of x raised to 1 is x square by 2. Now what I'm going to do is I'm going to take this half outside the bigger integration. Okay, in the next step. Fine. So this is equal to x square log x by 2, x square log x by 2. I've just rearranged the terms over here, x square log x by 2. Okay, it's a manner of writing. You can keep it as it is as well. If you're getting confused, you can just, you know, keep it as it is. Not a problem. Fine. Minus half. Now take this half outside. Minus half. Now this x square upon x. X square upon x becomes x dx. So this is equal to log x into x square by 2 minus half x square by 2 plus c. So this is log x into x square upon 2 minus x square by 4 plus c. This is the final answer. Those who have understood can just give me a feedback over the chat. Please share your feedback whether you have understood this problem or not. Okay. So this was the first question. Let us take the second problem. Okay. Exercise 5.5, question number 2. Integration x square e raised to 4x dx. X square e raised to 4x dx. Okay. So the first term is algebraic and the second term is exponential. A raised to x and e raised to x are exponential. Now, guys, tell me, is there a need to interchange this, to reshuffle the terms? Is there a need for it? Are we supposed to interchange the terms? The answer is no. There is no need for interchanging the terms because algebraic comes prior to exponential. Algebraic comes prior to exponential. So there is no need to interchange these terms. So this itself is u and v. Okay. So write the formula u integration v dx minus bigger integration dy dx of u smaller integration v dx bracket close dx bracket close dx. Okay. Yeah. Put the values x square e raised to 4 dx 4x dx minus bigger integration dy dx of x square e raised to 4x dx bracket close dx. Fine. Yeah. Now try and understand integration of e raised to 4x dx. Can you try what is the integration of e raised to 4x dx and tell me the answer? What is the integration of e raised to 4x dx? Anyone? Integration of e raised to 4x dx. Correct. Some students are replying. Integration of e raised to 4x dx will be e raised to 4x upon dy dx of 4x. So this will be e raised to 4x upon 4. So the integration of e raised to 4x dx is e raised to 4x upon 4. Is there anyone who has not understood this? Integration of e raised to 4x dx is e raised to 4x upon dy dx of 4x, which is 4. So wherever this e raised to 4x dx will appear in the problem, e raised to 4x dx, wherever it is getting appeared, I will write e raised to 4x upon 4. Okay. So the next step, x square e raised to 4x upon 4 minus dy dx of x square is 2x e raised to 4x upon 4 bracket close dx bracket close dx. Okay. X square derivative is 2x. That is what I have written. So this can be written as x square e raised to 4x by 4 minus, see now this 2 upon 4, this will become half and that half will be taken outside. And then we are left with x into e raised to 4x dx. Then we are left with x into e raised to 4x dx. Okay. Have you understood this? Is there anyone who has not understood this? Okay, now I need some suggestions from your end. How to integrate this? Integration of x into e raised to 4x dx. Yeah. So basically, the first term is algebraic. If you agree, then put a yes. The first term is algebraic. Yes or no? The second term is exponential. The second term is exponential, right? First term is algebraic. The second term is exponential. Okay. So this is u and this is v. It's in the same order. It's LAE. So algebraic and exponential, we don't have to reshuffle this. We'll keep it in the same order. Okay. So we are going to apply this integration by parts formula once again. So let's go to the next page. X square e raised to 4x by 4 minus half u integration of v dx minus bigger integration dy dx of u integration of v dx bracket close dx bracket close dx. So this is equal to x square e raised to 4x upon 4 minus half x e raised to 4x dx. We know what is u and v. U and v is x and e raised to 4x, right? Minus bigger integration dy dx of x integration of e raised to 4x dx bracket close and then curly bracket also gets closed. So eventually this is going to become x square e raised to 4x upon 4 minus half x integration of e raised to 4x is e raised to 4x by 4, which we have already discussed this, minus bigger integration box bracket the derivative of x is 1, derivative of x is 1 and integration of e raised to 4x dx is once again e raised to 4x by 4. Okay. The placement of brackets is very important in this problem. The placement of brackets is very important in this problem. Okay. Now what I'm going to do is I'm going to write this 1 upon 4 outside the bigger integration. All the rest of the things are quite sorted. You can take a look. Okay. So now we are going to take that 1 upon 4 outside. X square e raised to 4x by 4 minus bracket x e raised to 4x by 4 minus 1 upon 4 taken outside integration of e raised to 4x dx bracket close. Okay. So this is x square e raised to 4x by 4 minus x e raised to 4x by 4 minus 1 by 4 integration of e raised to 4x is e raised to 4x by 4 plus c. I'll show you the previous slide, see. And there is half outside which I missed on. I'll just write it. Please let me know if you're done with this slide. Okay. So there is half outside over here. So this is x square e raised to 4x by 4 minus half x e raised to 4x by 4 minus e raised to 4x by 16 plus c. Now, moreover, what you can do is you can just put this half inside the bracket, as in multiply that minus half with both the terms. You can do it on your own. Multiply minus half with both the terms. Guys, can you share a feedback of this problem? Have you understood this? Everyone, please. Yes, waiting for your reward. Okay. One extra problem. Now, mark this problem as a very important problem. Okay. Integration log x dx. Integration log x dx. Now, guys, tell me, is there any formula for integration of log x? There is no formula for integration of log x. Okay. So what I'm going to do is I'm going to write this in this format. Log x into 1 dx. It's a compulsory format whenever there are log problems. Okay. So the first term is u and the second term is v. V will be 1 compulsorily. We'll write down the formula. U integration v dx, bigger integration, dy dx of u, integration v dx, bracket close dx. So what is u? U is log x, integration of 1 dx, bigger integration, dy dx of log x, integration of 1 dx, bracket close dx. Okay, I'm putting the value of u and v over here. I'm just putting the value of u and v. Okay, done. Have you copied this? So whenever there is a log term, take v as 1. Whenever there is a log term, take v as 1. Fine. What is integration of 1 dx? Integration of 1 dx. What is integration of 1 dx? Hello. What is the integration of 1 dx? Integration of 1 is x. Integration of 1 is x. Okay. These things you need to know. So log x into x minus bigger integration. D by dx of log x is 1 upon x. And integration of 1. Integration of 1 dx is x. Okay. So this is dx. So this is log x into x minus integration of 1 dx, because this x and this x will get cancelled. So this is log x into x minus x plus c. That is the final answer. Guys, have you understood this problem? This was an extra problem. Okay. So whenever there is a log term in integration, take v as 1. Take v as 1. Fine. Let's take the next property which is required for us. The property is integration of e raised to x f of x plus f dash x dx is equal to e raised to x f of x plus c. Please copy this. E raised to x box bracket f of x plus f dash x dx is equal to e raised to x f of x plus c. Have you copied this, guys? Okay. Let's take one extra problem on this. It's an extra problem. Integration of e raised to x log x plus 1 upon x dx. Now, is this of the same category of that of the property which I've just specified? E raised to x, this thing is f of x plus this thing is f dash x. Okay. If f of x is log x, its derivative is 1 upon x, which is f dash x. Fine. So as per the property, this will be e raised to x f of x plus c. So which is equal to e raised to x log x plus c. E raised to x log x plus c. Yes. Anyone who is not able to understand this problem? This is a very simple problem which can be also asked for MCQ. Yes, guys, please tell me. Have you understood this? Okay. Next question. Exercise 5.5, page number 133. Question number 5. Integration e raised to x 1 upon x minus 1 upon x square dx. So this can be written as e raised to x 1 upon x plus minus 1 upon x square dx. This minus I have shifted over here and I've got a plus sign in between. And I've got a plus sign in between. So don't you feel this is f of x and this part is f dash x? Isn't it f of x and f dash x? Okay, so what is the answer for this? As per the property, and there is e raised to x outside, see? So e raised to x, f of x plus c, which is equal to e raised to x into, anyone? E raised to x into, correct, 1 upon x. Okay, please copy this. Yeah, go to exercise 5.5. I'm taking you to the next problem. Exercise 5.5, question number 8. Integration e raised to x log x the whole square plus 2 log x upon x dx. 2 log x upon x dx. Is this clear? So this is your question. So let this be f of x. If f of x is equal to log x the whole square, f dash x will be dy dx of log x the whole square. Guys, can you just calculate the derivative of this and tell me what is the derivative of this? Getting very few answers. Yes, I've got two answers and both are correct. Yes, you're not able to get the derivative of log x the whole square. Apply chain rule, come on. X raised to n formula. 2 log x into dy dx of log x. Others, you are not able to get log x the whole square derivative. Is there anyone who is not able to get this? If you need my help, please let me know. Okay, so this is 2 log x into d by dx of log x. Ideally, it is 2 log x raised to 2 minus 1, x raised to n formula. 2 log x raised to 2 minus 1 into d by dx of log x. So don't you feel this thing is f dash x? Don't you feel f dash x is 2 log x upon x? Okay. So we can apply the property e raised to x, f of x plus f dash x. We can apply this property e raised to x, f of x, right? Plus c. And what is f of x? F of x is log x the whole square. F of x is log x the whole square. Fine. I hope you are understanding the property. Okay. So that was your last problem for the day. Just a second.